Hey class, Mr. Houston here back for our last exciting episode out of Chapter 6, talking about similarities. We are jumping kind of back into similarity transformations, and we're going to perform some similarity transformations somewhat. A lot of the transformations they want to talk about here today have to do with coordinate planes and in coordinate notation. We're just going to talk about how you would find the points and what you would do with those points. We are not going to actually graph them because I think this will be a lot better for you as long as you've seen it rather than necessarily having to do it. But we are dealing again with dilations because dilations is the only one that changes the size of your figure. So you'd have similar figures instead of congruent figures. Okay, so if you remember, describing a dilation was with a scale factor, and basically to figure out the points of a new figure, you simply are going to take the points and you're going to multiply them by whatever the scale factor is. In this case, they call the scale factor k, and you just multiply each ordered pair by that k. If k is less than 1 but greater than 0, you're going to have a reduction, you're going to have a smaller figure. K is greater than 1, then the dilation is going to get your figure is going to get bigger. Okay, so example 1. It says draw a dilation of quadrilateral ABC with vertices A, B, C, and D using a scale factor of 2. I don't really want you to actually draw it. I just want you to figure out what A prime, B prime, C prime, and D prime would be. And so basically all you do is you take the original point and you take the scale factor and you multiply each point by that scale factor. So in this case, you're going to multiply both of them by 2. So A prime would be found at 4, 2. B prime, same thing. You're going to just multiply everything by the scale factor of 2. So B prime would be at 8, 2. C prime would be at 8, -2. And D prime would be at 2, -2. Okay, that is how you would do it with coordinate planes or in a coordinate notation type of thing. You just take whatever the scale factor is, then you multiply each ordered pair by that scale factor. Okay, so sometimes we'll be given a picture and we have to determine, is this a dilation? So basically, are the sides in proportion? So we are simply going to take a look. We have vertices A, B, and C. So that is here, A, B, and C. Whoop, did that backwards. But either way, we are going to then, we want to determine, is the image a dilation with scale factor of 1/2? So we could figure out the length of each side and then figure out the length of each side here and determine if they're in a scale factor of 1/2, or we could figure out what these ordered pairs would be if we apply the scale factor 1/2. So let's do that. So A corresponds to D, and 1/2 times 4 is 2, 1/2 times -4 is -2. B corresponds with E, half of 8 is 4, half of 2 is 1, and F would correspond with C, which would be 4, -2. So we'll go over here, and we'll determine D is at 2, -2, so 1, 2, 1, 2, so that checks. E is at 4, 1, 1, 2, 3, 4, 1, and F is at 4, that should be -2, not +2. So we'll go 1, 2, 3, 4, 1, 2. So these all check out. They're good. So therefore, this is a scale factor image or a dilation of ABC, giving us DEF, a 1/2 scale of that. All right, and example number 3, where they want us to find the scale factor. Remember, scale factor is the new figure over the old figure. Okay, so you're making your own photo stickers. Your photo is 4 inches by 4 inches. The image on the stickers is 1.1 inches by 1.1 inch. What is the scale factor of the reduction? So you're going to take your new, which is 1.1, over your old, which is 4. You can attempt to reduce this. When you have a fraction on top, actually you have to reduce it. You're not allowed to have not a fraction. You're not allowed to have a decimal in a fraction. So the first thing I would do is move this out over 1 and move this out over 1, so it becomes 11 over 40. You can't simplify 11 over 40, so we would just leave it as that. And again, just to clarify that, you can't have a decimal in a fraction. So we moved this over 1. We technically multiplied both the top and the bottom by 10 to eliminate that decimal in your problem. Okay? All right, so that is just a brief overview of scale factors as it would apply to coordinate notation and coordinate planes. Should you have any questions, bring them with you to class, and we'll see you then.